See, now we are discussing about the binary search. That means the main intention of using binary tree is the binary search. That means you need to search whether the element is there or not. That is what your objective. And why you need to use binary search instead of, like, if there is an array, if you want to search for any key element, it will obviously take big of n times, right? At max it can take big of n times. So this is not a good thing because the time complexity is more. But in binary tree, that will be reduced drastically. Like, it will take big of log n times, which is very good. That is why people use binary search in order to search for any element in any element. So how it works? Normally, you know, right? First, you are going to create. How you are going to create, you should know. How you are creating binary tree? First, you will add 10. That is a root node. Then the next element that you are adding is 5. Imagine that you are adding 5. Then you will search, check whether 5 is less than 10 or not. If it is less than 10, then you are going to add as a 5 as a left child of the 10. If the element that you are adding, right, if it is greater than 10, that means in this case 20. If it is greater than 10, then you are adding as a right child of the 20. So that is how it works, and it goes on. And it should have always 2 child, or it should have 0 child. That means it should have this is a condition for binary tree, but that is why we call it as binary. That is meant by 2. It should have 2 child, or it should not have any child. So imagine I need to search for 7, whether it is there or not. First you will come at 10. Okay, 10. 7 is less than 10. Yeah, it is less than 10. So go to the left child. Okay, I went to the left child. So I saw it is 5. So whether 7 is greater than 7, 5? Yeah, it is greater than 5. So move to the right of the 5, right to the right child of the 5. So I went to the right. There I got 7. So I will return. Yeah, 7 is there. That is how it works. So first of all, I will write a code for that. After that, it will be easier for you to understand when I draw recursive tree. So what I am going to return is, I am going to return, imagine I am going to return node itself. So I am returning node. So I need a node. I will take x as a node. Okay, x is equal to recursive search. I am doing, right? Recursive search. In this video, I am going to do both recursive and iterative search. Okay. Then recursive search. Then I am going to pass the root value. Okay, root node I am passing. So root is the most important thing in binary tree, because why we are going to use only root? Because we have only in memory this binary tree will be there, but we will have access only to this root node. Like just in because we are using linked list, right? In linked list we will be having only control of the first node. Similarly in tree that will be happening. So let me pass root node, and let me pass whether this element is there or not. Check for whether 20 is there or not, right? After that, it is returning node, right? So it is fine. Then what I do is I will print that element. If it is there, it will print that element. Means if 20 is there, x data, that is 20, should be printed. Okay, now I am going to write the function. It should return what? It should return node. Node. It is a pointer that I am returning, right? So node asterisk I am going to use. Then I took the function name as recursive search. Let me just copy this one because I am going to use it much more. Okay, recursive search. Okay, I am going to take node, root node as p. Okay, then I am going to take element as let me take it as key. Okay, then if that node, see, if p reaches null, what you return me is null. You return me nothing, right? Then if that p data, if it becomes equal to key, then you got that element. Then what you do is return me that node itself. So that is what the node I needed. Else if key becomes less than p data, means somewhere key is there at the right side of the tree. So return me that function, but this time you send me p left. Right, p left you send me, because I need to search for left side. I will go through the tree, that is left side I am going to go, because since key is less than p data, so I will send the key also. Then else if key I think if I give else, that is okay, but still for our understanding I'm going to give key is p data. If it is key is greater than, then what you do is simply return me the p right child then key. So that is how it works. Okay, now if I run, I should get the result, right? Let me see whether I get 20 or not. Okay, it is showing some error. Let me see what is the error. Else without a previous if. Else without a previous if. Okay, if statement else. Okay, I have given semicolon. Okay, then I will run. It should work fine. Okay, it is working. I am going to give like 7 elements I need, and those elements are 10. Again, same example what I took earlier. So 5, then 20, then 2, then 7, then 15, then 25, 20. Yeah, I'm getting 20. That means I forget about this result. These are the previous video, you can go and watch. This is for sum. I think this is counting the parent notes, then this is pre-order, post-order, and yeah, you can see in a previous video. Then 20 I'm getting. So that means we have searched for that element. So let us go and see how this works. For that, let me take this function also. Let us take and try to draw recursive tree. Okay, I am going to draw here itself. I'm going to paste that one here. Okay, I pasted. Let me enlarge this. I'll enlarge to 28. Okay, it is clear. Now, first of all, what you are sending here? You are sending. Imagine the key that you need to search is 7. Again, same example that I took earlier. 7 you need to search. Then the root node you are sending, that is 10 you are sending. Check whether p is null. No, it is not null. So check whether p data is equal to key. That is, check whether 10 is equal to 7. No, it is also not possible. So go to else if. Check whether 7, that is key, is less than p data, that is 10. Yes. Then what you do? You go to the, again you call the recursion. At this time, instead of p should have a p left. P left is what? P left is 5. Left is 5. Node 5. So you go, now I am sending 5 here. So for node 5 I am going to send, and key will be same, again 7. Then again this will be failed, and this will be failed, and again this will be failed. Again key 7 is greater than 5, right? This will be passed, and this time I am going to send p right child. That means I am sending 7. Okay, then again here it will be 7. Then if p is equal to null, no, it is not null. We have data in it 7. Check whether p data is equal to q. Yeah, it is true. Then you return me p. That is how it works. That is how recursion will work. Now let us write a recursive iterative method to search for the same thing I am going to do. Let already I have created. See, I am just copying this thing. I'm pasting this. Instead of y, I am going to x. I am going to take y. Then y should be, let me call it as iterative search, IT search. Okay, then I'm passing root and 20. Again I'm passing 20. Let us take the same example. So I should get 20, right? So yeah, it should work. Then I'm going to write the code for that. The code is almost same. Again it should return this thing. Then IT search, I think SER search. Okay, I'm going to copy. So it is not recursive, right? So I'm not using that again. So again int key, same thing I am doing, but here instead of recursion what I do is y that p isn't equal to null. Then what you do, you see this represents p isn't equal to null. P isn't equal to null. That is what the equivalent of simply taking p. if you want to represent p is equal to none, at that time you what you do is simply give like this should work. But now let me take if p isn't equal to null. So if it is not equal to null, go here. If that p data, if it comes equal to the key, then what you do is return me that p. Okay. Else if that key what you are searching, right? Okay, what you are searching is less than p data, at that time what you are going to do, right? What you need to do is you can't write recursion here. You can't write. At that time what you do is you will return me t left child, you return me. Okay. Else if again key, if it is greater than p data, what you are going to return me? You return me p r child. Okay, r child. Let us see whether it will work or not. 7 again 10. In same example I'm going to take 5, 20, 2, 7 and 15, I think, then 25. So 20, you are getting 20. So it is again, like, iteration is so much easy, right, to understand. So iteration is this: if you are getting p data, you simply send it. If you are not getting, then what you do is you can make p, see, instead of this you can simply make p is equal to p left. I think it should work. Let us see whether it will work or not. Make p is equal to p right child, so it should work. Let us see. Okay, now again 7, 10, then 5, then 20, then like again 2, then 7, 15 and 25. So we are getting the result. See, it is so much easy. If it is equal to, means if p data is equal to q key, you need to return, or else what you do is you make p as p left. If you make p left, then it will go here, then it will find it is not null, then it will come back again, it will check. So normally it will work like recursion itself. So I think you have understood this one. So you can look at the playlist of binary tree. You can have completed most very large number of topics here, like pre-order, post-order, counting in order, counting leaf node, counting parent node, counting all number of all the nodes, sum, then it search, and I'm going to further continue this binary tree. It will be so much easier for you. And so thank you.